Welcome to ModPath Chat, the official podcast of modern pathology, featuring interviews with authors and experts on the latest science, technology, and developments in the field of pathology. Our host, Dr. George Netto, is the editor-in-chief of Modern Pathology and professor and chair of pathology and laboratory medicine at Perelman School of Medicine at the University of Pennsylvania. Here's Dr. Netto.
Hello, everyone. Welcome our viewers and listeners to a new episode of ModPath Chat, a bi-weekly podcast that is now can be viewed also at YouTube channel, the USCAP YouTube channel. So uscap.org/ModPathChat. If you go there, you can enjoy, this is, I think, the 79th episode, and you can enjoy seeing our amazing guests. Before I introduce today's distinguished guest, I want to mention that we will be taping live an episode in Baltimore during the annual USCAP meeting in the exhibit hall. So those of you who are attending, you're welcome to drop by and meet the speakers of that specific episode, which is going to focus on the long course. So with that, I want to welcome today's guest, my friend and colleague and ex-resident, I should say, Justin Bishop, who really been a tremendous success story, an expert in head and neck pathology with a special interest in salivary gland molecular path, and really helped discover a lot of underpinning of some entities. And he's here today to talk about one of his recent publication with collaboration with the Memorial Group. Justin is now the chief of anatomic path at UT Southwestern, and he has an endowed chair, and can't believe it, already a professor. And he is also one of our important members of our team of associate editors that really help us with Modern Path. So with all that, welcome, Justin, and thank you for accepting my invitation.
Thank you for having me. I'm a big fan of yours, George, as you know. So great to be on with you.
Thank you. I appreciate your help on the journal. And let's dig into this article. But before we talk, and it's about polymorphous adenocarcinoma, I guess refining what are the molecular alterations, they are a comprehensive analysis, let's say. Before we talk about that, tell us a little background about this entity. I grew up calling it polymorphous low grade.
Right.
So what's changed and what's the latest in the WHO classification for this?
So, yeah, I mean, I think it was kind of initially described in the 80s. It was kind of a newer entity in the early 80s, variably called polymorphous low grade and terminal duct adenocarcinoma, sort of noticed to resemble in some ways lobular breast cancer and its growth pattern. But I guess polymorphous low grade kind of won out over terminal duct carcinoma, and PLGA. Yeah, that's how I was trained too. That's what we called it. And so it was one of the new entities that broke out after kind of the classics. Was a big change in the 80s when it was called, kind of recognized, because it used to be, they were all called adenoid cystic. And so obviously those would be expected to behave much worse. And so there was this kind of subset of oral cavity tumors that did much better than you would expect for adenoid cystic. And that's what ended up being this polymorphous low-grade adenocarcinoma. So I forget the exact order of the changes, but at one point in one of the WHOs, it was kind of desired to remove grade from the name, the terminology, the tumor names, basically. Mm-hmm. And it makes some sense because not all of these are low grade. Usually they are, almost all, but not all. So it was made for a very awkward situation when you call something a low grade, your polymorphous low grade, comma, intermediate grade or something. So getting that low grade out of there was kind of important. And then there was sort of a controversy, gosh, it would have been, maybe 15 years ago or something, where sort of group was describing what they purported to be a new entity that they called Cribriform Adenocarcinoma of the tongue. And they said they sort of speculated that maybe they arose from vestigial thyroid tissue in the tongue, even though they didn't express thyroid markers. They did have some resemblance to like papillary thyroid carcinoma. And so sort of a push to maybe recognize this as a new entity. So there's, maybe polymorphous, and then maybe this cat tumor were kind of floating out there. And then some very fine work by Christina Antonescu and Alon Weinreb kind of showed that both forms, both cat, cribriform adenocarcinoma of the tongue, and polymorphous low-grade had alterations in PRKD family of genes. They had been able to sequence one or two and found that some of them have hotspot mutations, some of them have fusions. The fusions were more often seen with the cribriform type, but not exclusively. And same with the point mutations, usually seen in the classic type, but not exclusively. And so then the understanding sort of evolved to say, okay, these are basically ends of a spectrum, that this PRKD gene associated polymorphous adenocarcinoma. You have the classic type, usually point mutations. You have the cribriform type, usually fusions, but there's a big in-between gray zone. And that's kind of how things have evolved, and that's where the WHO has it now. So now it's polymorphous adenocarcinoma family, and then you can have classic, cribriform type, and then sort of an intermediate type. It's a lot of words, but that's the 40 years of development of this tumor.
Wonderful. And you put it in maybe 40 seconds or 80 seconds. So very well done. And so it's the classic where a molecular underpinning make for a unifying concept of the entity, and going now by the new WHO standards, we don't call variants anymore. So you're using subtypes for each one of these. So it's a Cribriform subtype, and like you said, the classic subtypes, as you indicated. So I thought that was already in the WHO. So why did we accept this beautiful paper? What's new in it? Why did we do it?
So, and I'll say too, that this is all happening, I kind of failed to mention, under the backdrop of salivary gland pathology and sort of a molecular kind of revolution that has happened over, 20, 25 years. So sort of kind of slowly but surely recognize that most, if not all, of the low grade, in particular, low to intermediate grade salivary gland tumors, benign and malignant, harbor some sort of defining genetic characteristic. And most of them, it's fusions. So adenoid cystic has MYB, the MIB fusion, mucoepidermoid carcinoma, mammal 2. So we're kind of experiencing the same revolution that a lot of subspecialties have, maybe a little bit, maybe 10, 15 years behind soft tissue, for example, but sort of the same kind of concepts and challenges that arise from these concepts we're going through now. And so polymorphous adenocarcinoma was just one of the long line of entities sort of found to be defined by these particular genetic characteristics. And so when that work was done by Christina and Alon, this was kind of before RNA-seq was really easy to do, or off paraffin tissue. So I suspect they did it off of a couple of cases they had frozen. And then from that work, it was FISH all the way. So all of this work that had been done on polymorphous adenocarcinoma was done by FISH analysis, which is great and very powerful. But we sort of knew or suspected that we didn't have the full picture of what was going on. So for adenoid cystic, for mucoep, we knew not only the key gene, mammal 2, but we also knew the partners. For example, mucoep, it's very consistent, CRTC1 or 3, and it's always those two genes. Whereas with adenoid cystic, it's much more variable. NFib is the most common, but there's a lot of different breakpoints and there's a lot of different gene partners. And we just didn't know. I mean, because it was all this work was done by fish, we just didn't know, what the story is with the partners. Maybe it would be very consistent, maybe not. And unlike some of these other tumors, there's a couple reasons that this remained kind of ambiguous for so long. One is that there's usually low grade and they behave pretty well. And so we're not getting a lot of Caris or, sequencing for treatment targets, because usually they do pretty well after surgery only. And so we're not getting a lot of sequencing by, from the oncologist point of view. And then two, what we also discovered is that most of these panels do not have PRKD 1, 2, or 3 on them. Even our own at UT Southwestern, which was very big, very comprehensive, 2,500 plus genes, we still did not have, to my surprise, PRKD 1, 2, or 3. So our collaborator, Dr. Gagan, had to specifically add those so we could even do this study. So there was a couple of reasons that this had kind of puttered along without kind of knowing what the partner genes were for so long. It's kind of unheard of, right? Like most tumors where we know kind of the genetics, we know the complete story. We know the fusion partners, both partners, but it was kind of surprising to us that this had gone so long without really knowing the full genetic story of this tumor. So that was our impetus, and we were able to get a number of tumors together and save a little money to complete the study.
Wonderful. So many of the people you mentioned, our collaborator, including Alon and Dr. Gagan and a group from Memorial Sloan Kettering. So I imagine this is a multi-institutional. So the cohort, if I got it correctly, you started with 54 cases, and on 51 of them you were able to do NGS. Any specifics about the cohort that you were selective in, or pitching for anything?
So good question. Right. So most of these cases came from my and Dr. Weinreb, Dr. Hahn, University of Toronto, just our sort of consult practices. And we selected specifically Cribriform subtypes or intermediate. And the reason we did that is because we know that those are the types that are most likely to harbor fusions. Because we were trying to actually discover something new, namely the kind of exact fusion partners. We were really trying to enrich the group as much as we could for those that were most likely to harbor a fusion. Now, if we had all the money in the world, we would have been completely comprehensive and sequenced all comers, classics. This was we got some reviewer pushback on that, and I don't disagree with them. That would have been great. But ultimately, this was already a very expensive study. Sequencing is expensive, and with as many cases as we got, we had to kind of limit our scope just a little bit. So yeah, they were cribriform or mixed intermediate types of polymorphous adenocarcinoma that we limited our focus to.
With the premise that, as you mentioned initially, those are more likely to have the fusions. So let's move on. So you had results, I think, on 38 cases, and 28 turned out to have fusions, and 10 had the PRKD1, 2, 3 mutations. So a significant number of fusions, but there were some surprises there in terms of promiscuity of partners, correct?
Absolutely. I mean, we fully expected that we would have a number of PRKD fusions, particularly PRKD1, and certainly we got some of the fusion partners that had already been described. But yeah, I mean, we were also expecting we thought it would be likely we'd find a lot of novelty, and we did. And so yeah, we had 51 that we sequenced, and 28 had a fusion, and 13 novel partners. So that's pretty good yield, and that's kind of what we were hoping for, and that's kind of what we got. Yeah, and only 3 of the novel partners were recurrent. So just a lot of one-offs. It seems sort of more adenoid cystic-like in its genetics than it is mucoepidermoid-like in its genetics. Mucoep, very consistent, always the same breakpoints. PRKD, much more variable. You're right. The partners are quite variable. In terms of surprises, yeah, I mean, I was a little surprised we got 10 cases out of the 51 that actually had the point mutation. We knew this. We knew that it doesn't always sort out that way, classic with the point. But 10 out of 51 of, an enriched group still had this sort of more classic-like, genotype with the point mutation. That was a surprise. And then, yeah, some of the novelty was surprising. There was one particular case I want to focus on. So just a slight side tangent here. Another kind of entity that we were able to describe apart from this is called microsecretory adenocarcinoma. And this is a new tumor type that sort of defined by SS18 fusions with MEF2C. I hadn't heard of it either, but SS18 we know of. Anyway, that's another one that's very consistent. Always the same genes, always the same breakpoints. And that tumor has a lot of overlap with polymorphous adenocarcinoma. They're always oral, cavity, same immunophenotype, even some morphologic phenotype, but also enough differences and genetically different. So we had one case that was in this cohort found to have both SS18 with, I think it was PRKD 1 or 2.
2.
So yeah, 2, I think. So anyway, it's a tumor that already has some overlap with microsecretory adenocarcinoma. And this is a really bizarre case that genetically has mixed features of both. So I still don't know the best way to classify that particular tumor. And if you look at it, there are areas that look microsecretory. There's areas that look like polymorphous. So this is what I mean when I say it solves some problems, but causes some problems too. Like if we're going to a genetic classification, okay, well then how do you classify that one? It has features of both. So yeah. Those are some of the surprises we got.
Yeah, and just for our audience, ARID1A and B were the most frequent partners among those. But then one of a bunch of partners, CATIN-MB. You mentioned the SS18 and Actin-1 and a bunch of others highlighted in Table 1 and Table 2 with some beautiful images. So what is the practical point? Now, you mentioned this is not, clinicians don't ask frequently to do sequencing of salivary gland tumors or polymorphous especially. So you think there is a diagnostic beside the conceptual and understanding of this entity and finally, clarifying, shedding light on the fusion partners. What do you expect practically?
Yeah, good question. I mean, I do think that there is value in just knowing like what the genetics are of a tumor that we diagnose every day. So I do think there's inherent value there. But you're right. I mean, these are not often candidates for targeted therapies because it's usually a pretty well-behaving carcinoma. So I don't think there's a lot of, at least at this point, targeted therapy enthusiasm for this particular tumor type. So yeah, I would say that there's some value diagnostically to knowing not only that PRKD 1, 2, and 3 are the genes of note, but actually the partners. I mean, a lot of times we don't have both genes on whatever panel you're using, and so as I mentioned, many platforms do not have PRKD 1, 2, or 3. So if you don't have either partner, then you're going to miss the fusion entirely if you're seeking some sort of genetic confirmation. So I think just for completion, it's good to know like what is the spectrum of possibilities. And so even if you don't have one, maybe if you have the other, then you'll be able to at least catch that fusion. So yeah, I think there's diagnostic utility, and then just the kind of conceptual knowing Knowing what is driving these tumors, I think, has value.
Absolutely.
This is true for a lot of salivary tumor pathology. Whenever I speak on this topic, a lot of times I'll get somebody in the audience saying, "So what?" Like, who cares? And I have to acknowledge that, yeah, there is not a lot of targeted therapy going on in salivary gland pathology in general. And a lot of tumors that we are talking about, mucoepidermoid carcinoma, this microcirculatory, most of them are low grade. And so, yeah, I mean, most of them are being treated by surgery, maybe radiation at this point. And so I have to, sort of acknowledge that, this isn't something like actionable at this current moment, but more of a way of kind of refining classifications, solving diagnostic dilemmas. And I guess if you don't know what the genetics is of a tumor, then there will never be the possibility of any sort of targeted therapy. The first step is figuring out what are the genetics of this tumor. How do we clarify the diagnostic part of it, and then you can move on to maybe a therapeutic application.
Fully agree. No, I didn't mean to minimize.
Not at all. It's a good question
of that discovery, but I wanted to focus that. I think it's diagnostically that is important. These are tumors that can, for people like you and Alon, Dr. Han, probably are not a problem, but for a lot of us, maybe having doing a FISH or doing a sequencing could be helpful in these particular cases, given the good behavior and implications. And as you mentioned, in the past, they used to be overcalled as adenoid cystic, and definitely you don't want to do that. Well,
yeah, I mean, I'll give you an example of this is what really happened. This is a sinonasal tumor that had, again, mixed features of polymorphous and microcirculatory adenocarcinoma. And the pathologist did the SS18 FISH, and it was positive, thinking that would solve the dilemma. But no, actually, as a matter of fact, this tumor did have that weird fusion where it had PRKD fused with SS18. So now we know that, that won't necessarily solve your diagnosis. If that is your differential, that won't necessarily solve it. And now we know that, and that's useful.
Great study, and I really thank you for everything you do for us, for the journal. And I know it's a lot of work, and I'm proud of your success, and I'm grateful to your contributions to the field in general, and more selfishly to our journal at USCAP. And we will have you back on a podcast just to talk about salivary glands and discoveries in general. I don't know many people who can be provide such expertise in a very simplified way to our audience on a topic that is really somewhat complicated for all of general pathology.
It's very kind. I don't know how simple I made these things in this conversation, but it's very nice of you to say. I do my best. And it's my pleasure to work on Modern Path, and an honor, really. So thank you.
Thank you.
Any opinions expressed in this podcast are the speaker's own and do not represent the views of Modern Pathology, Elsevier, the University of Pennsylvania, or USCAP. Your ModPath Chat host and scientific director is Dr. George Netto. The producers are Dr. Catherine Ketchum and Carly Hess. Technical direction is provided by Kaminsky Productions. Music by Mitch Neubauer. Thanks to the authors, reviewers, and editors of Modern Pathology for making this podcast possible.